Okay, so right here, you should be able to see pretty easily when you're looking at these triangles. Do all the sides have the same ratio? 2 to 1, 2 to 1, 2 to 1. Okay, they're all proportional, so these would be similar by SSS similarity. Okay, probably the least often used one. Okay, let's go to an example of AA similarity. Okay, let's say I give you this information. So 2 triangles, this is the only piece of information I give you, other than, let's say, I give you these sides. Okay. And I want you to solve for x and x. Okay, if you're looking at this set, okay, the fact that in these 2 triangles, and I'll label this so we can identify what we're looking at. Okay, we have 2 triangles, this large triangle ACE and this smaller triangle BCD. Okay, these lines are parallel. If the lines are parallel, we know that corresponding angles A and DBC are equal. Okay, we could also say this other set of corresponding angles are equal, or we could say this shared angle C is equal. Okay, but right there we have AA similarity. So we have a pair of congruent, or a pair of similar triangles here. So if we were to name the similar triangles, ACE is our large outer triangle, and what point in the smaller triangle corresponds with point A? A corresponds to B. What point corresponds to C in the large triangle itself? And then E corresponds with D. So here's your similarity statement. The justification is AA similarity. So what this means is your sides are proportional. Okay? Now, if I ask you to find x in this case, okay, you can find x. Okay? X is not a side by itself, but it is part of a side. What side is it a part of? It's a part of AC. So when you set up your proportions, once again, it doesn't matter how you set it up or which one you choose. I'd strongly encourage you to choose your unknown. Whatever you want to solve for, start with that on the top left of your proportion or your equation. And I'll explain that here in just a second. So if I start with AC, that's my unknown. That's what I want to solve for since x is a part of that. Okay, what side does AC correspond to in the other triangle? And you can look at it right here. The first 2 letters, so it corresponds to BC. And what could we replace BC with? BC has what value? 4. So I could either write BC or I could directly write in its length 4. Okay, I'm doing both just to show you where these different things come from. Okay, and so once you get your unknown over its corresponding side, you then need to find what pair of sides in the 2 triangles do you have specific values for. So we have a value for AE and BD. Do those correspond to each other? AE and BD. Yeah. So you can set up your ratio AE over BD. So this is the pair. This is the pairing that you would choose. You could plug in your values for that. So AE was 20, BD was 3. And so here's your equation. Now, the reason why, you could set this up any different way. You could say 4 over AC is equal to 3 over 20. It winds up all working out in the end. The reason I'd say to start with your unknown first is it just makes your solution easier. Because now, instead of having to cross-multiply and then divide to solve for your unknown, all you have to do is multiply by whatever's in the denominator here. So if we just multiply both sides by 4, you're able to isolate that variable because it's already in the top left. And then just multiply through. Nothing reduces here, so 20 times 4 is 80 over 3. So AC is 80 over 3. And so what would we have to do to this in order to solve for x? Subtract 4, and 4 is how many thirds? 12. And so 80 thirds minus 12 thirds leaves your answer of 68 thirds. Okay, so you're able to solve for your unknown by finding the whole length, removing the portion that you already know, and you're left with what you're trying to solve for. Okay, but this was an example of a similarity. Right, the last type that you will see, and again it'll show up on story problems, would be something kind of like this. All right, so let's say we have these intersecting pieces. We have two isosceles triangles here. So we know that the sides of these two triangles are going to be proportional, right? Because they have the same ratio, 8 to 20 and 8 to 20. Is the included angle equal between those? Yeah, these are vertical angles, so vertical angles are equal. So we do have SAS similarity here. We have a pair of proportional sides and the included angle being equal. So we have similar triangles. So the relationship that we can identify here is triangle WXV is similar to. So W corresponds to which angle? Could W correspond to Y? Could it correspond to Z? Yeah, it could be either one of those, right? So let's say we choose Y. X corresponds to the other base angle Z, and V corresponds to its vertical angle pair, which also labeled V. So here would be your similarity statement. And so when you're looking to solve for X, our solution X is this side, WX. So if we begin with that side, WX corresponds to what side in the other triangle? YZ, the first two letters. YZ has a value of 7, so we can insert that. And then we just have to find the corresponding set of measures. And so we can choose either of them. Let's say we chose WV, since that's labeled. WV is 20 over its corresponding side is YV. YV is the same length here. It's 8. And so once again, it saves time by starting with your variable because your solution simply involves reducing your fraction. 4 goes into 25 times, 4 goes into 8 twice. Multiply both sides by 7 to get your x completely alone. And when you do that, you wind up with your solution 35 halves for that problem.